recording again. I was just going to point out before we go, I did put this document. It's now on the Focus Aphasia page where you all found the Zoom. And this just has some helpful tips for doing actual coding. If you want to code your own transcripts, we're going to work off of pre-coded things off of AphasiaBank, which if you don't have access, I gave a little blurb here. Once you have access, you can download the transcripts, which we will be working with today. And I gave you a little link. So I just wanted to full disclosure that before I turn the floor over to Davida. And if people want to follow along, I gave a little glimpse of 4 of the commands that we'll be talking through, and then the actual commands are down here below. All right, so with that, I'll stop sharing. And Davida, if you want to start, and then we can kind of go from there.
Okay, sounds good.
And feel free to, if you want to turn your videos off, you're welcome to, or you can turn them on, whatever your pleasure.
Okay, so quick question. Let's see, before we get started, how much time do I have?
I reckon you and Sarah Grace can have most of it. If you guys give me maybe 10 minutes at the end, I just wanted to point out, how to look at some paraphasia things with qual and just reiterate another use of the frequency command.
Okay.
So maybe you,
all right.
Sarah Grace 20, and I can bring up the rear.
No problem. If I start going on too long though and lose track of time, just yell at me.
Okay.
Okay. As you know, and Sarah Grace knows, and anybody who works with this stuff, it you can get really carried away with it. And there's so much interesting, good information, and I'm excited to share it. So, okay, so let's get started. I am going to show you how to do some analyses with the eval command. And this is one of many commands in the CLAN program. And this command was designed specifically for aphasia clinicians, but it's also proved to be very useful for researchers as well. Let's see, as I think we may have explained here in the cheat sheet that Bree put together, the eval command is a composite profiling command. So you run one command on one chat file, 2 chat files, 100 chat files, whatever you have that you want to analyze, and you get 34 outcome measures that are analyzing aspects of that transcript or all of those transcripts. So it's one command that produces this composite set of 34 discourse outcome measures that are likely to be ones that are relevant to aphasia. So before I start, let me show you where you can read about the eval command. So let's see, I'm going to switch to my big monitor here because it's much easier to work with. So if you're at the TalkBank website, which is talkbank.org, you can go to the CLAN manual, which is right here. You click on the CLAN manual, and then when it comes up, you can search for eval, and it'll pop you to that location in the table of contents. You can just click there on the page number, and you get to an explanation of the eval command, all the measures, those 34 measures I told you about, and then an eval demo. So it's another opportunity, another resource that you can go to. And then if we go back to the TalkBank website, another thing you can do if you're interested in learning more about this command is to go to the AphasiaBank webpage, which is here, and then go over here to publications. And then then you can click here for a bibliography that has clickable links. And there are two articles. One is by Forbes et al. In 2012. So I would search for Forbes and look for the one here, this one down at the bottom, Forbes et al. 2012. And you can just click on the link and it'll pull up the article. And then there's another one, which is a relatively new one. So let's see, I guess it's down at the bottom. These are chronologically listed, and it's from et al. 2020. Let's see, here we go. This one, using AphasiaBank for discourse assessment. And again, if you just click on the link, it pulls up the article and it tells you more about the eval command and various others. So those are resources that people can use to learn more about the command. All right, so let's get into it. The first thing we'll do is open up the CLAN program, and this is the CLAN commands window. I have my working directory set to a folder on my desktop called Friedrichsen, which has some files from the Friedrichsen corpus that we have in AphasiaBank. And so the first thing I want to do is show you the files that we're going to be analyzing. So these are various participants, O1A, O2A. If there's an O3A and an O3B, it means that that person was seen multiple times, usually separated by several years. So we're going to look at Friedrichsen O9A and O9B today. And just to orient you to the chat transcript, it tells us that this person is 63 years, 7 months old. He's a male, he's got anomic aphasia, and his WAB-AQ was 90.2. And then you have a full transcript of speaker tiers, the investigator, the participant, the morphological tier that's under it, the grammatical relations tiers. Those are automatically created by the more command. There are different what we call gems, which are just different speech tasks. So there's free speech, and then there are different picture descriptions, storytelling, procedural discourse tasks, and so forth. So anyway, this is a big, long transcript that we have on this person, and we're going to do analyses on this transcript. Okay, let me move this out of the way so I can access my buttons here. Okay, so I'm going to close this file now, and I'm going to do the first command, which is I'm going to use the drop-down menu here for programs, and I'm going to select eval. I want to do the eval command. I want this profiling set of composite scores on Friedrichsen O9A to see how he did on one of the tasks. Let's say we're interested in how he did on the Cinderella task. So then I click this option button. Let's say I want to look at Friedrichsen O9A. So I select that over here and I say add, and looks like I already had O9B in here. I want to remove that because I just want to look at O9A right now. So I say done. And now I say that I just want to look at the participants' utterances. I don't care about the investigators' utterances. I don't want to compare him to the whole AphasiaBank database, so I just deselect the database. We'll do that later. And then down here, it looks like I already selected the Cinderella gem, but if you wanted to look at how he did on his stroke story, you would click that. If you wanted to get rid of that, you just unclick it. But let's look at how he did on the Cinderella task. You can select all gems, you can deselect the gems. But anyway, we'll look at the Cinderella task, say okay. And then what happened here is that because I used this drop-down menu and all those buttons, the command got written automatically. And what the command says is, I want to run the eval command. This symbol is in place of the file name. So that's where we did that first step where we selected Friedrichsen 09A and put it in that box. This says I want to look at the participants' utterances. I want to look at the Cinderella gem. And the plus U, it is just saying send the results to one file. We're just looking at one file here, so we would only get one file output of results, one spreadsheet. But if we were looking at 09A and 09B or the whole Friedrichsen folder, we would, and we want them all to go to one spreadsheet, we have to have this plus U to say send the results just to one output file. But if it's here, it doesn't matter. So that's what the command says. So then I hit run. And when I get here, it tells me that it looked at Friedrichsen 09A.chat, that was the chat file, and it created an output file, Friedrichsen 09A.eval.xls. And that file is in the folder now. You can see it here, right underneath the 09A chat file. So I could open it from there, or I can actually just triple click right here, and then it just asks if it's okay to open it, and you say yes. And let me make this bigger. Hold on one second, I have to keep moving this around. Okay, oops, hold on. Okay, so then we get this spreadsheet, which shows the Friedrichsen 09A file name here and some of that basic information from the top of the chat file. And as we scroll over, we start to see the data. So we see that it was 193 seconds in duration. There were 28 total utterances. The MLU in words was 4.48, MLU in morphemes. The types, of course, is the unique words used. The tokens is the total number of words used. Then we get a TTR, words per minute, verbs, how many verbs per utterance, the percent of word errors, percent of utterance errors. Those obviously have to be coded into the transcript by the transcriber. Then there's proposition density, followed by a whole bunch of parts of speech data and morpheme, morphosyntactic data. How many past participles, how many present participles, prepositions, adjectives, adverbs. And these are showing in percent. That's the default mode. I'll show you how you can run this and get raw numbers if you want. If you don't want to know percent of determiners or percent conjunctions, you want to know actually how many were there. Then there's a noun to verb ratio, open to closed class word ratio, number of open class and closed class words, and then the number of retracing, which are revision markers and repetition markers that were in the transcript. So if a word was repeated, there's a way to mark that when you're transcribing. And if a word was revised or corrected, restated, there's a way to mark that when you're transcribing. So you get a sense here of these kinds of behaviors that were in the transcript. Okay, so that was just a straight up look at Friedrichsen 09A's Cinderella. Now, I guess the next thing I wanted to show, oh, let me do this. If I hit the up arrow on my keyboard, it brings up the last command that I used. Now, if I wanted to do that with raw numbers, I could just add plus lowercase o and the number 4. And that's just the switch in the command that says, give me raw numbers instead. So then I hit run, it analyzes it again. I can triple click here. I say, yes, please open it. Let me make this bigger. And let's just scroll over to where all those lexical and morphemic items were, and we see now we're getting number of nouns, number of plurals, number of verbs, numbers of all these things, not percentages. So that's all you do is you add the plus lowercase o 4 to get raw numbers. Okay. Next thing I want to show you how to do is to compare Friedrichsen 09A to Friedrichsen 09B. So let's say you've done some kind of treatment program, or you're following someone longitudinally for whatever reason, and you want to see how their performance changes over time. What we can do here is, again, we could write the command in manually. Oops, I could hit that up arrow and I could get rid of that at thing, because I told you that's where it selects the participants, and I could just write in the file names. Let's see, I could write Friedrichsen 09A.chat and Friedrichsen 09B.chat, just separating those by a space. And this is saying run the eval command on the participant, looking at the Cinderella gem, send the result to one file, give me raw numbers on these two files. We run it, and it shows us, it looked at 09A, it looked at 09B, and it gives us one output file. We say yes. And then we make this bigger. And I am going to actually tell it to freeze the first column. But anyway, we see 09A is on row 2, 09B is on row 3. We can see that there was 5 years separating these two visits. He's still tested as anomic. Actually, his AQ was 90.2 the first time, 88.2 the second. But we can look at how his performance on this task changed. The duration was much longer, total utterances much longer, MLU about exactly the same. Types, so many more types, and tokens. Again, so this is just, we don't have to go through every single one, but you get the point of how you can compare over time. And you can do, as many files as you want, and compare them and get these data output into one spreadsheet. Okay, let me get rid of this. Don't save. Okay, if we wanted to do that command automatically, we would just go to eval, and then here at options, I'd put 09B back in there. Add, done. Again, we don't want to look at anyone else in the database. We just want to look at Cinderella. I'd say okay, and that would run the same thing. And again, those two files are just hidden under that at command. Okay, 2 more things to show you, and then I'll be done. How am I doing with time? Okay, I'll do these really fast. So let's say we want to compare 09B to the other people with anomic aphasia in the database and see how he compares. All right, let me erase this. And I would go to programs, eval, option. Let's say I just want to look at 09B, his most recent one. So I'm going to remove 09A. Now I just have 09B here to analyze. I say done. Now I am going to select that I want to look at all the anomics. And this guy's 68. So we can say, let's just look at people who are between the ages of 58 and 78. Let's say 10 plus or minus his age. And if we want, we could also say we just want to look at other males, because maybe we think there's something about Cinderella and gender. And we've selected Cinderella. We say, okay, it writes the command for us. It says we're running eval on the file we selected, looking at the participants' utterances, comparing to anomic males in that age group, looking at Cinderella, sending to one file output. And again, we can triple click here say yes. Again, I'm going to freeze the first column there. And now, let me get rid of, okay. Now, the information we have when we do comparisons is that it tells us what the mean of the database is, the minimums, the maximums of all the people that we selected who had anomic aphasia, were male between the ages of 58 and 78. There were 49 of those. So it gives us all the data about them here. And then in this row, it's going to tell us if he's 1 or 2 standard deviations off from that comparison group. So if we look across here, we see that his MLU in words is lower, 1 standard deviation lower than the mean of the database. We keep going across. If there's nothing in this column, it means that he's close enough to the average of the anomics. Here, his percent word errors is much higher. His percent utterance errors is much higher, or his number of utterance errors, I think that is. Let's see. Yeah. And otherwise, these look like he's pretty comparable. So that can be useful information. Oh, pronouns. He looks quite a bit higher, so he's using a lot more pronouns. Again, so this is a way to compare a person to the database. I'm going to close this. I'm not going to save it. I'm going to show you just one thing. If we wanted to get that, to do that same thing and not have percentages, but get raw numbers, again, just a space and add the plus 04, and we would get the raw numbers. Let me show you one more thing, and then I'm going to quit. And this is kind of similar. If we wanted to compare this person to the controls, we can still keep 09B, say done. Now, instead of anomic, let's say we want to see how he compares to the control group. And we can keep it the same age range in the males. We'll keep Cinderella. We say, okay, we get the command and hit run. Triple click here. Yes. Enlarge this. There were 38 in the database that fit the age and gender. Let me freeze this. And then if we scroll over, we'll see more places where he's more different from this comparison group, because these are the controls. So 2 standard deviations off on MLU in words, 1 standard deviation off in the number of unique words that he produced, and so on. So you see a bunch more places where he differs. And he had a very high AQ, as you recall, like I think it was 88 point something at this testing. So this guy's pretty mild, but you can still see a bunch of areas where he's 1 or 2 standard deviations different from the controls. So I'm going to quit. Sorry for going so long. I hope that was clear, and I'll be happy to answer questions later. Okay. Let me
I have a question.
unshare.
Can I ask a question?
Oh, yes.
Oh, so there are several small questions. What does the U stands for in the coding, the commands?
In the command, plus
Yeah.
U just means send all the results to one output file. So for example, if you're looking at Friedrichsen 09A and 09B, if you didn't have plus U in there, you would get 2 spreadsheets. But if you want to see them both on the same spreadsheet, it says send the results to one spreadsheet. If you're only looking at one file, it's not needed. But the command just puts it in because, you know, when you do it automatically, just because it doesn't matter.
Okay, another question, thank you. Another question is, what is the difference? You mentioned a little bit, what is the difference between the retracing and between retracing and repetition exactly?
Repetition is if you repeat a word,
Repeat the same
multiple-
word.
the
and
same
then
word. And
retracing.
yeah, so if I said the prince went to look for Cinderella, those would be repetitions. If I say the prince went, well, no, he sent his people to look for Cinderella. So you might indicate that that was a revision.
Revision. Okay, revision more.
Revision could also just be a simple, word correction. The princess was whatever, so there's lots of different reasons for revisions, but revisions are some kind of restatement of something and or correction, and repetition is just the same word.
Those are all in the chat manual, by the way.
Oh, okay. So another question is, so if I want to select all the participants, this eval by certain AQ something like 85 or like 93, then is it also possible to do with this option?
I don't think so. I don't
Okay.
think that's one of the options. I think the options are just the ones that are there, which is age and gender and aphasia type.
I think one of your articles, I think you kind of divided by AQ, like above anomic and below anomic. Then how did you kind of separate it out?
Okay, maybe we should talk about that after we get through the other commands, because that's a little bit off of the command topic, but I'll be happy to talk to you about that later.
Thank you.
Yeah, that just goes back to that Excel spreadsheet when you look at more than one person. But yeah, we can definitely chat about that. I'll turn the floor over.
Let me just throw one more thing in. Let me unshare. But I mean, you saw that in the output, you get the aphasia quotient scores because that's part of the information. Anything in that header line that I showed you prints out in the spreadsheets. So once you get, let's say you look at everyone in the database or all the anomics, if you just want to pick ones with certain AQs, you can do that through the spreadsheet. Thank you, Bree, for mentioning that.
I have a question about, I'm sorry. I have a question about the one of the options. So when we select the gem, there is the gem saying the stroke for aphasia, but actually in the control group, it is the sickness or illness. So if I select the stroke gem, it will be automatically converted to illness or sickness?
Ooh, good question. I don't know.
For the RHD bank or for?
Let's see.
Yeah, just when the control participants have to talk about an illness event instead of their stroke event. So yeah, does the database compare those two? I hadn't ever thought about that.
That's a really good question. Okay, well, Sarah Grace is talking. I'm going to email the programmer and find out.
Okay, thank you.
That's a hands-on workshop. Hands-on.
Yeah.
Yeah, it's live. It's alive is what I want to say. Like by the end of the session, that might be added to the program.
Love it.
Okay.
All right, we'll turn it over to Sarah Grace.
All right, so I am going to walk us through, if you know that you have kind of more specific interests than the eval program, because the eval is really, really broad. It's going to give you lots of great information, but you might feel like you're drowning in data a little bit. So the fret command can let you kind of dive into a little bit more specific. So I'm going to show how to use the gem command to just pull out a specific story or task that you're interested in, and then use the frec command to evaluate it. So let me share my screen. And so we're going to just be looking at the ACWT corpus. This is from the Aphasia Center of West Texas. So that's kind of the data that we're looking at. So assuming that you've already downloaded this onto your computer. So I've set my working directory to be that ACWT folder. So Clan is going to go pull this set of transcripts to do all of my commands on. And then I am going to be pulling out just the specific gem that I'm interested in, which in this case is going to be the sandwich, the PB&J sandwich procedure. So this is the command that we are going to use. So I'm going to ask or tell the program to use the gem program. We're going to look for the sandwich gems in each transcript. We're going to pull those out and make them their own separate files and add this sandwich tag to the file so that I know that this is not the full transcript, it's just this sandwich transcript. Again, like Davida, I only care about the participant tier, so we're going to just pull the participant tier, not the investigators. I want to keep the morphological tier because we'll use that in the FREC commands later. And then the star.cha is just a way to say, I want to run this command on all of the chat files in the folder that's my working directory. And then the +n and the +d1 are just modifiers for the output. So +d1 tells the program that I want this to be in legal chat format. So I still want the heading information so that I can still have, you know, the aphasia type, the WAB-AQ, all of that information. And then +n just says that each gem ends when the next gem begins. So there's not a specific marker that says this is the end of a gem. You just look, you count everything until you see the next @g tier in the transcript. So let me show you what I mean by that. So we have this @g speech, which shows this is the start of the kind of speech task. How are you, how's your speech doing these days? And then if we scroll down, we have another @g, which is the stroke story. So tell me about your stroke. And there's no marker to indicate that the speech task has ended. It's just this @g line. So that +n modifier here tells the program that we're just going to go until you hit the next @g line and pull everything before the next @g. So I'm going to close this transcript. And right now, my output is set to my working folder, so that ACWT folder, but I actually want these to go into a different folder so that I'm not getting myself confused. So I'm going to tell the output to go to this ACWT sandwich folder. So I have all of my sandwich transcripts in their own folder. And so you can see it updates now to show that it's going to that specific folder. So we'll put in our command, and you can see right now that the only things in this folder are some cut files. So I'm going to run the command, and you should just see over here the transcripts popping in. So the Clan output window here is giving a report on whether it was successfully able to pull the specific gem out of each transcript. And so we can see here that there are a couple of transcripts, ACWT 03, 05, 08, and 11, that they didn't find a sandwich gem in the transcript. And so it's always good to keep an eye on this output and make sure that if there are missing gems, you can go back and figure out why. The sandwich task is I think probably the most common that this happens with, because if you've given the AphasiaBank protocol, you know that we ask individuals to tell the sandwich procedure without any kind of like visual cues. But if the individuals aren't able to tell the story, then you can provide them with a picture of the ingredients and ask them to try to tell the story with those ingredients. And so that production of the sandwich picture, or of the sandwich task with that picture, is coded as a different gem. And so what you see here for ACWT 03 is that they had to tell the sandwich procedure with picture supports. And that's really important. We don't want to include those necessarily in the same analyses as the individuals who didn't need that picture support. That seems like a kind of qualitatively different task. So we won't worry about it. But occasionally, you know, sometimes the person who's transcribing might have accidentally like misspelled Cinderella. This is also sensitive to case. So if they've like forgotten to capitalize a letter, you might end up not pulling out a gem, and even if it is there. So it's always good to go back and check for those that are missing. Okay, so we are done with this ACWT folder. So I'm gonna close it for now, and we're just gonna focus in on our sandwich transcripts. So I'm now going to change my working directory back over to this specific set of sandwich transcripts as well. So now my working directory and my output directory match. And so the CLAN program doesn't say it twice because they're the same folder. So that is the gem file, and you can change what you put here. So this is because I was interested in sandwich, we wrote sandwich. But if you were interested in Cinderella, you know, you would just put Cinderella. If you were interested in the broken window task, you just put window. So whatever the name of the gem is, it goes here. And then whatever tag you want to put on the files so that you know which specific story or which specific task it is, you put in there. So you can see that because I put the sandwich tag here, it gave me this dot sandwich in the middle of the file. So now I am going to rename the file type. So you see that running the gem command also changes the file from a .cha to a .cex. And the frec command doesn't play as nicely with the .cex file ending. So, so we're just going to really quickly change the file ending. And that's a thanks to Davida. I actually just recently learned this, but you can see there. So we ran this command, and now all of the file endings are back to .cha. And so this one is very simple. You have your ren for rename is the program or the command. The old file name or the, you know, whatever it is that you want to change about the old file is what goes first. And then whatever it is that you want to change about, you know, change it to is what comes second. So I said star because I wanted this to be all of the files in the transcript. And then if it ends in .cex, and then I wanted to change all of those to chat format. Okay, so now we're ready to actually look at the frec command. So the frec command lets you determine how often a specific word or behavior or linguistic characteristic or other thing is present in the transcripts. So for this first, I'm just going to demonstrate looking for a single word. So in the sandwich task, we're going to look and see how many of the participants actually produce the word jelly. And we're going to send this to an Excel spreadsheet. And so what we'll see in our folder up here is that it will populate that Excel spreadsheet. And it uses the FRQ to show that this was a kind of a frec command. Again, we open that up. My computer gets angry about triple clicking, so I'm not using the trick that Davida showed you because my computer is old. So here we get each of the participants in the folder, in our working folder. It gives us some basic information out of the header tiers. So we have the age, sex, aphasia type, and then we can see that almost all of them used the word jelly when telling the peanut butter and jelly sandwich. So if for some reason you were really interested in a specific lexical item, this is a really easy way to figure out if people are using that lexical item. What this really gets you, I think what is a little bit more interesting is using a cut file to look for multiple lexical items. So along with some colleagues, we have developed the core lexicon lists for all of the AphasiaBank stories. And these core lexicon lists are just kind of the most typical word usage. And we, Davida helped us create this cut file, which just contains a list of words. And let's see. I don't know if you guys can see that okay. But these are just the A and bread, butter, get, it, jelly. So these are the core lexicon items for the sandwich task. And so using this cut file, we can actually tell the program to look for each of these words in all of the transcripts at the same time. And this also lets us look for kind of the basic lemma. So we would, for butter, we would be able to count butter and butters, maybe even buttered. So any version of that word is going to get counted using this cut file. Don't save. So let's run that really quickly. So the same in terms of the command. So here, instead of telling it to look for a specific word like jelly, we're telling it to go look for this file sandwich.cut, which is in our working folder. And then again, we're telling it we want to look at all of the files that end in that sandwich.cha, and we want to send this to a separate spreadsheet. So when we hit run, there we go, it gives us our output. And this time you see that there are just a lot more columns. So for each word, we have a column and we can see which participants produced that word and how many times they might have produced it. So that's really helpful. This is, a very easy way to score a core lexicon or some kind of like word list, core vocabulary list that you might be interested in. And at the end, this provides the types, the tokens, and the type token ratio. So essentially, if you're looking for, how many of the unique words in your list the individual produced, you can just look at types. If you're looking at how many times did they say these words total, you could look at tokens. So that you have that kind of right there. You don't even have to write a formula for it, which is very nice. So if you were interested in something that wasn't necessarily like a lexical item, you can also look for things like actions. So here, this is a command that would let you do kind of like a gestural analysis. So gestures or simple actions are coded with this ampersand equals tag and a description of what the action is. So here, I'm interested in looking for any of these simple actions and see, how many simple actions and what kinds of simple actions are present in the transcripts. And so here, the plus S is what we're looking for. So we're looking for these simple actions. The star indicates that it's any action. We don't care, you could put in here a specific word. So it could be like waves hands. And so you could look only for the action waves hands. But here, I don't care about what kind of action it is. I want to find them all. And then the plus O modifier is just telling the program to sort these by order of decreasing frequency. So we want to see the most frequent action first, followed by the next most frequent action. And then I didn't put in the plus D2 modifier. So this is actually going to give me the results directly in the clan output. And so what we see here is that for each participant's transcript, we know who it is. We see that it's looking at that speaker tier, and then we see each of those simple actions. So twice there was something that was just coded as a gesture. Twice the participant pointed to the table. Twice the participant traced a letter. one time the participant gestured like moving their hand over. So probably showing like you put the sandwich together, that kind of action. Once the participant groaned, and one time the participant maybe did something with bread in their hand. So maybe they like used their hand to show that it was a piece of bread. You also can see like slicing or scooping out, if they talk about scooping out the peanut butter or scooping out the jelly, so, or spreading it. So those are all different kinds of gestures that you might be interested in, and seeing what kinds of gestures are being used to help support the storytelling by these participants. So, you know, I think that can be a really useful command there. And then the last one that I wanted to highlight, I think I'm okay on time, so I'll show this one. You can also, so far what we've looked at are utterances or behaviors that are coded in the participant tier. And you can also look for utterances, or, you know, a behavior or a feature that is coded in the morphological tier. So here I'm asking the program to look and find all of the plural nouns in the transcripts. So again, if we run that output, we'll get the output straight to the clan output window. We'll sort it by decreasing frequency. And what we see here is that ACWT used one plural for pieces of bread. O2 used one plural for slices of bread. O4 didn't use any kind of plural noun, neither did O7. O9 used 4 different slices, so bits, kids, slices, and triangles. So again, you know, you could, if you were interested in a specific morphological marker, you could look on the morphological tier. So that's denoted by that M. And then the -PL says, you know, I'm looking for plural. You could also look at the third person singular. You could look at if they're using like determiners or adjectives, any of those kinds of things. You can use the freak command to look for. So I think that's all that I had to share. Any questions about that? Davida, any comments?
That was great. Beautiful.
All right, well, if there aren't any questions, we'll let Bree go ahead and jump in and share her tips and tricks with you.
Yeah, for sure. I think Davida has an announcement.
Yeah, an announcement. So it was a great question about would the stroke gem automatically analyze the illness or injury gem in the control files? And the answer is no. It won't automatically do that. But I think it's a good idea that we add that as another gem option to select in that part of the eval program. So I've already written to the programmer to ask if he can add that in, and then you could compare to controls, and you would just select stroke and stroke gem and the illness or injury gem, and it would find whatever, you know, gem the transcript had, and it would send the results all to the same worksheet. So thank you for the question. It does not do it automatically, but we should add it.
Thank you so much.
We learn things all the time. All right, so I'm just going to finish up with 2 very brief commands. For those of you who know me, know that I really like to look at errors and paraphasias or word-specific errors. So I was just going to show you 2 things that I commonly do to look at these things. You can also substitute in utterance level codes for this. So I'm going to show you what I do for like a word level code. So in these examples, I'm going to look for anything that's tagged with *S, which is a semantic tag. And that can be semantically related, unrelated, unknown, and a variety of different things, like it's a semantically related preposition, or it's a perseveration on something. So anything tagged with *S, and those are usually following words in the transcript that you tag as being errors. So I really like these types of paraphasias. So I wanted to show you, if you are also interested in this, how I look at these things. So in my clan, let me go ahead and pull it up. Hopefully, can you see both my commands and my, okay, great. So in my command window, I'm on a Windows, so it probably looks a little bit different. They kind of differ depending on what type of operating system you're on. But I have two codes that I have already plugged in. The cool thing about this is if you press the up key, it'll show you your most recently used codes, and I use the up key all the time. So you can see I'm just kind of rotating between the two. I'm in a folder which has all transcripts from only the broken window gem, just as an example. And you can see here that what I'm going to ask it to do first is something that Sarah Grace was showing, which is the FREC command, which stands for frequency. But I'm going to ask it to look on just the participant tier, not the interviewer. And I'm going to ask it to pull out as a count all instances where words are tagged with the *S. So something that's a paraphasia that's semantically oriented. As we've shown before, plus D2 will put all of my chat files of interest, combine it into a single worksheet, which I'll show you in a second. And I also wanted to show that another way to grab all the files in a folder, depending on their ending, is just to use this type of a call. So if your files, for instance, you can see here, mine all end with .cex because I pulled them out as gems earlier, which is what Davida showed. So if you want to go ahead and pull those, you can just call for anything tagged with that ending. If they're labeled as a chat file, you can also do that. So anything that's in your folder. So if I run that, it's going to run it. It's going to be angry at me because I didn't do it right, but I already did it. So don't worry. It lives already. You're going to get something that looks like this, which is going to be the frequency output that probably looks a little bit familiar given what we've just seen. You'll see again, the file name, right? You'll see all of the demographic information that's listed within the chat file. And then of interest to us, you're going to see over here instances of error types. So for instance, if you go to the chat manual, you'll see that this thing means it's an unknown but real word error. This one means it's semantically related error, and so on and so forth. I'm actually in the qual output. Sorry, let me switch really quickly. It's the same general thing, but here's the frequency output. You're going to get a raw number out. So for this participant, they did a single *S paraphasia, and it was an unknown. But this other participant down here in row 7 had 2 semantically related paraphasias and 1 unknown. So that type of quantitative output is something that could be really interesting, right? If you're comparing across different subtypes or different aphasia quotients, as Sue was mentioning earlier. The other one I want to briefly show you, and I mistakenly showed it to you there, but this command called qual, or kwal as I call it, which is probably not right. And what it does is very similar to frequency, but it actually is going to pull out the utterance, the language where the thing you're looking for. So again, in this case, semantically tagged things. It's going to pull out the utterance where those are present. All right, so if I run that, and I did it previously, so we'll just jump over there. You'll see this sheet where if you scroll all the way over to the right, you'll see all of the different utterances pulled out word for word from the transcript, and you'll see where that error is tagged. So this person has said, when they're trying to describe the picture, it's all big, right? And it was tagged as big being an unknown here. Now, something to note about qual, which is different from FREC, is that qual is going to give you 1 row per the thing you're looking for. So you'll see here, ACWTO3, who is a participant, has made 3 different instances of the semantic paraphasia. So we get 3 rows for that person. Whereas in the frequency output, you're just going to get 1 row per person, and it's going to give you raw numbers. So this is really nice, this qual, because it gives you more data to look at and really get to analyze and perhaps look at stuff like context around what the error was. So with that, I'll stop sharing so anyone can ask questions if you'd like. And this again will be all posted on YouTube later, but that cheat sheet of all the commands we use today is on the website currently right next to where you found the Zoom link, and it'll stay there even after we kind of move it to past presentations. So you can go in and use our cheat sheet if you'd like. So we have 3 minutes for questions if anyone has any other questions.
So it looks like I kind of wonder that what's the usual order of the sorting data by your interest. So like you choose the story first and then just look up the story, sorting story, and then just go narrow down like by AQ and types later. Seems like
that's one way to do it. I mean, if you're interested in a specific task, that's the way to do it. Maybe if you're interested in all tasks, right, you want to kind of compare across. So it really depends on your research question. I tend to be someone who likes to compare across tasks. So I separate my gems and then I can pull out all the information of interest and then do whatever statistics I want to do on it later. So comparing semantic errors on broken window with those made on the Cinderella task or something like that.
I was thinking sorting by AQ or types first, but it seems like it's a little bit difficult to do that probably. Yeah, okay.
It's probably easier to go by task or by the language element or gesture element that you're looking for. But I use eval first just to get a look at the data. And then I almost always use frequency next just to get a look at the data. And then I use qual to say like, okay, so what is this error in my instance? So I use those 3 commands a lot.
Yeah, thank you. This is really super helpful. Yeah, and really deep actually. Yeah, wow.
Yeah, I think it's important to remember, like I think we did a good job here of showing that how many different ways how many different pieces of information you can get out of that same, that frequency command can be really, really powerful. It's not just a simple word count. It can do so much more than that. So, if you have that question, then you're like, I need to know how many times this happens. The frequency command will probably be able to get that information for you.
So the core lexicon you did a study, is it about whole this AphasiaBank or for each story, each task?
There's a core lexicon list for each task that we've developed, and those are available. There's like a discourse analysis webpage on the AphasiaBank website, and the lists are available there. And we also, I think with Heather Harris Wright and Hannah Kim at East Carolina, they have also developed some core lexicon lists for some other stimuli items or stimuli. And so there's a compendium that we published earlier this year that has all of the core lexicon lists that these 2 groups have created for the different sets of stimuli. So that might be a good, so you're not just, AphasiaBank obviously I think is really great, but there are also other stimuli if there are things about the AphasiaBank stimuli that are not ideal for your question as well.
Yeah, as long as you code it using the chat codes, you can do anything you want with CLAN, which is great. I also wanted to put a plug in for this Google group called Chai Bolts. I'm probably going to pronounce that wrong, but it is where Davida and Brian and Leonid, who's the programmer, will answer any questions you have about chat coding or CLAN commands. And they're really quick at it. I mean, I typically get an answer in like less than 24 hours. And you can also search for other people who have probably had the same question, which I really like. So you just join it and you can ask a question anytime and they'll point you in the right direction. So that's also a really good resource called, if you just Google like Chai Bolts Google group, it will show up. Wow, we're on time. Look at us go.
I'm going to throw in one more thing just to make us go over. No, I just want to say that those spreadsheets that you get after all these commands are kind of fake spreadsheets. They're really like glorified text files. if you actually want to save them and do anything with them, you just have to make sure to go to save as. When you're in Excel, it opens up, it's in Excel, it looks for real, but you want to be sure to save it as an XLSX workbook so that you can do stuff with it. I mean, it's fine. It's, you know, it's there, it's got stuff, but if you even just want to, you know, add up something or do anything more with it, you really want to save it as a workbook. So just beware of that.
Yep.
Yeah, I have made that mistake more
Me
than
too.
once in my history.
First thing I do now is like save as.
Say that,
Yes.
right.
Yeah, my
Excel
current like workflow is open it, save as XLS, and then do all of the things.
Right.
Absolutely.
It's, okay.
Awesome. Well,
Super.
with that, we're only 2 minutes over. I'm going to call that a win. I'll
That's
stop recording and we'll put it on the YouTube site and publicize it around. And if anyone here has any further questions, I think this is probably going to be a series at some point. So please send either Sarah Grace, myself, or Davida any questions you have, and we'll add it to kind of what we want to do for future workshops. Awesome. Great to see you all.
Thank you so
so
much.
much. It was
It was
great.
good. Thank you.
Thanks.
So helpful.